Hello, everyone. My name is Josh Rickard, and today we're going to talk about Atomic Operator. Atomic Operator is an open source project that I released that is a Python execution framework for the Atomic Red Team project by Red Canary. Today we're going to talk about, what Atomic Red Team, or a little bit about myself first, and then we'll go into, what the Atomic Red Team project is and what it's for. And then we'll go into Atomic Operator, as well as the features and functionality, and a little bit of why you would use Atomic Operator. And then we'll go into more of a demo. I would say overall, half the presentation is going to be slides, and then the other half is going to be a demo. So in about 20, 30 minutes, you'll get to the actual demo. So let's get started. Again, my name is Josh Rickard. I kind of have a weird background. I think at least. I started a help desk. I actually did that about 6 months, maybe, and then kind of moved into a system support role where I supported a lot of group policy, um, deployment of a large amounts of operating systems. Let's say thousands of computers using MDT, SCCM, things like that. And then really kind of moved into a system administration role. After doing that for a little bit, I actually was recruited to go and work on the security team because I had a pretty keen knowledge of Windows internals and how it worked. So I worked on the security team and focused mostly on digital forensics, some IR, but mostly on the DF side. At that point, I wanted to automate everything. I actually worked at a higher education place where there wasn't a lot of money, a lot of budget at that time, and security was kind of um, wasn't a shiny thing. And try to automate around phishing, phishing response, vulnerability management, and anything else that we could because we had to build it. And I also started to release a lot of open source tools at that time. I actually released an Outlook reporter button or whatever I think it was 2015 or 14, and released that online. And then got my last job, which was at FishMe/Cofence, and I did that for 3 years. Took their reporter button from I think 1 million to 18 million installs in 3 years, my team and myself. And I was getting into management and all that, and decided to kind of make that switch and moved into my current role, which is a was a security research engineer, and now I'm a security solutions architect at Swimlane. So you can find me on Twitter at MS Administrator. I also, MS stands for Microsoft Administrator. And then github.com slash MS Administrator as well. And you can find me on my blog at letsautomate.it. You'll also notice this unicorn headpiece here. That's actually me. I just love that thing. But you'll see also that my video just disappeared. That'll happen occasionally throughout the presentation. Don't be worried, I'm still here. All right, now let's get into it. Over time, as we've evolved in security, we've kind of needed a way to manage risk or manage the way that an attacker thinks from a defensive perspective. We have tried to do this. I think the first, instance of this that we're probably all aware of is the attack kill chain, which was a really, really good attempt at its time. It kind of laid and paved the path for what we all know as the big standard now is mitreattack. Mitreattack is a framework from MITRE that for enterprise, and they have other different frameworks. They have one for ICS, and they have Prereq, which I think is getting merged in or did get merged in. They have mobile, and there's others, I think. But what we need to understand is that mitreattack is is strictly data around adversarial, so actors, malicious actors, their tactics, techniques, and also just general common knowledge. But it is a framework. It is something that we need to understand that it is a framework. So here is a typical example that you'll see for a lot of MITRE ATT&CK. This is their dashboard on their site. It is really kind of laid out in a very great way to kind of digest from beginner to advanced. You have a list of what we call these columns, or what we call tactics. And so the tactics are the individual, let's call them phases that an attacker could go through. Not that they will, but they could go through. And so not all of these we may not even know because we don't have visibility or whatever it is, but we understand that an attacker performs this kind of chain of actions. And it's not that they have to go one to the other. They could jump. Maybe we start off at execution or initial access. Maybe we don't know anything about the reconnaissance or whatever it is. So with that, we have those individual tactics, and underneath each tactic is a list of techniques or sub-techniques. And those techniques are how an attacker could accomplish that tactic. So, for example, resource development is the tactic. Some of the ways that they could accomplish that is by establishing accounts in your environment or compromising accounts before they get that initial access. Maybe they found leaked creds online, whatever. That they're building those resources, or they just acquire infrastructure, right? Staging for their C2, maybe staging for their malicious code, binaries, whatever. But they're doing that resource development at that point. So you have to understand that not all of them, again, are going to be something that we know or we can know, but each one of these, one or more techniques or sub techniques, are how an actor could perform or acquire their goal or that phase or that tactic. I hope that makes sense. But as I mentioned, we have to really understand that MITRE ATT&CK in general is just a blueprint. It is not a prescribed, you must do it this way. You must use all of our functions and all of our data to understand your risk or understand how an attacker may attack your organization. That is not true. It is a literal blueprint and a framework. As the kind of name that is what framework means, is it is a blueprint. It is a guiding principle that you can use to in your environment, but you will alter it and you will modify it to your needs. Certain techniques, even tactics, are not applicable maybe to your organization, right? So, or to a certain environment, or a certain set of hosts or services within your organization, right? So you have to kind of mold it in to fit your needs, and that's a whole other topic on how to do that. But it is a blueprint, and it is a way to kind of give that guiding light and provide a way to build defensive posture against common, again, tactics, adversarial tactics, techniques, and common knowledge. It is all about utilizing data that they've acquired, that they have researched, they have gathered from others, and build out this entire framework that is based on real life information. As that evolves, so will the framework. So one of the things, again, we have to understand that it is not a prescribed, you must do it this way, you cannot get MITRE ATT&CK certified, blah blah blah. uh, you literally use it and adjust it to your needs. So hopefully I beat that with Yeah, hopefully I'm off my soapbox. So, some things that we need to understand here are also the different components, I guess, of MITRE ATT&CK itself. So, MITRE ATT&CK is made up of a lot of different objects or entities. And one of those, as we know, are going to be pretty basic. It's going to be techniques. These are different ways that someone may capture evidence, or I'm sorry, may capture credentials, right? Um, you could do it via memory, they could do it via brute force, whatever it is. I mean, there's a lot of different ways and a lot of different techniques to acquire depending on that tactic and that phase. Also, again, the tactics, which we are pretty familiar with, so we can roll up and we understand that these techniques belong to this phase or this tactic, or multiple. Mitigations, MITRE also provides these sets of mitigations that are linked to techniques. So we understand that from a technique perspective, they have provided these mitigations that we can use. Usually they're pretty high level. They don't go into, block this port or maybe they do, but like these event IDs, they're beginning to with the data components and all data source features that they're adding. But there's still, a lot of work that needs to be done there and a lot of research. But we have a way to understand that what these tactics, we can view all the mitigations for that phase. But again, not all of them are going to be applicable to us. We can also see that relationships between the techniques and the actors. And actors are malicious APT groups or malicious groups. Um, just basically, they're they're hackers, right? And or groups of them. And so they've defined these based on again research and data and reports and so on and so forth to gather this information. And so they kind of broke down, these actors and understand their different techniques, which then allows us to understand the different phases that an attack or an actor could perform. But it also gives us the ability to see what kind of mitigations we can look at from an actor perspective. If we're trying to prevent APT1 or whatever to from hitting us, we can look at those mitigations and understand the different phases that they have taken to perform their different techniques. So we also have these other relationships, our malware and tools. So we can look at it from an actor's perspective where we have known malware that they have used, known tools that they have used, and we can actually relate those now to different techniques. So we can say that this tool is going to be used in this tactic or in this phase, and this very specific use case or technique by this specific actor. And here are some mitigations for it, right? So there's a huge web of interconnectedness within MITRE ATT&CK, which is really ingenious and really well done. And I think that they put a lot of thought into it and a lot of feedback from the community to kind of build this framework to help us secure our organization, our environments, and our world. So kudos to MITRE. Love them. I love the framework. I think it's awesome. So this is a little bit of how we can understand MITRE and MITRE ATT&CK. But we also have kind of some gaps there, and this is where we'll get into a little bit of where Atomic Red Team is. So let's take, for example, command and scripting interpreter, which is the technique, and PowerShell is the sub technique of that technique. So we can see that it is T1059 dash, or I'm sorry, .001. PowerShell is very familiar, I think, to almost everybody. If you have Windows in your environment, you're probably using PowerShell in some fashion. So you can look and they'll show you all the different what they call procedures. They mean different events or APT groups that have used PowerShell and they know this. They'll actually have data sources that you can use and permissions and blah blah blah. All this kind of defined. But for this one single technique, we must understand a lot of information. Right? We need to understand for this single sub technique Adversaries can use PowerShell to perform any number of actions. Oh man, any number of actions or a number of actions, whatever. It's still a lot. We can understand that they can use it to execute code. That's pretty self-explanatory. We understand that they can use start process. You have to understand what a commandlet is. And they can actually run just an executable, or they can run invoke command. So we have to, again, understand what those can do. We also need to understand that there's a lot of different tools, offensive tools, and other tools out there that are written in PowerShell, like Empire, PowerSploit, PoshC2, PSAttack, so on and so forth. And they can actually just execute it straight from PowerShell.exe, the binary, or from the included underlying DLL of system.management.automation.dll, which is just exposed through the .NET framework and Windows CLI. So again, why I'm showing you this is that this is just one technique, one sub technique. And I don't know how many there is, maybe 300, whatever, different techniques, or maybe that's way off. I just don't remember. But we have to understand it at that level across all of these techniques, and it's almost that's impossible for anybody to remember and know that information. I mean, if you do, please let's talk, because I want to dump your brain, I guess. But what I'm saying is that there's a lot of information, a lot of knowledge and expertise that we need to cover the entirety of mitreattack. Luckily, the fine people, I love Red Canary, right? I think they're an awesome org and what they're doing, and giving back. They started the Atomic Red Team project many years ago, and it has exploded. And a lot of people give back to it, and a lot of people participate in it. But I just wanted to give a huge shout out to Red Canary for doing this. They even have a very specific community manager for their open source tool. They have lots and lots of dedication towards this project. So kudos to them. Again, Atomic Red Team is where we're going to focus. This is the logo. As you can see, it's an atomic. It has Red Canary, in the center, but it is a complete framework around mitreattack to help us test and prepare. So they have their own website. It is Atomic Operator, or I'm sorry, Atomic Red Team, I think .io. Man, I should have looked at that. But it's, basically there's a lot of different projects under this umbrella. And there's Atomic Red Team, which is the actual test. We'll go into that. There is a PowerShell-based framework similar to Atomic Operator. Actually, many years ago, I think in 2018, I rewrote what Invoke Atomic was to an actual PowerShell module. It has since been taken over by many other great people. So, yeah, but I have a kind of a history around, I guess, Atomic Red Team and Invoke Atomic. They also have the Atomic Test Harness project and Chain Reactor. Both of those I have not fully used, so I'm not an expert in that, but I am part of that Slack and will help wherever I can. So to explain a little bit about Atomic Red Team, Atomic Red Team is really a set of tests, or what they call atomics. And those tests are used to emulate, or they're supposed to emulate or simulate, depending on your OSE knowledge there, the mitreattack techniques used by malicious actors. So let me refactor that. So these tests are supposed to help with identifying certain techniques and how they could be used against you by malicious actors. So it's a huge repository. I think there's like 800 or man, I should have looked at that too. But there's a lot of different tests, and I'll explain what that looks like. But one of the key pieces that we must understand with Atomic Red Team and that entire project is that it's all about preparation. Just like with digital forensics or incident response, preparation is key. And one of the huge goals that Atomic Red Team, I think, provides is allowing us to prepare, so we can actually know what we can and cannot detect within our environment. Allows us to test things. Also, I think Atomic Red Team in general is a huge learning tool for people just getting into cybersecurity. Understand these techniques and look at the code, look at the examples, look at all of that, and actually run it just on your machine, like a demo VM or whatever. It'll allow you to understand how an attacker could abuse something or how they could look at something. Helps from a defensive perspective and also an offensive perspective. So it's a great knowledge tool for anybody trying to learn individually. You want a great resource? That's probably one of the first things that I would tell you. So here's an example of what this looks like. This is one atomic, and this is for PowerShell again. And it's going to have a brief description of, from MITRE, but it's going to list all the different tests. One thing that we must understand is that each one of these techniques or atomics can have one or more tests. Some of them will have just one. Many, I think, just have one. But then you have ones like PowerShell is extremely common. I think there's like 12, 14, 15, something like that, different tests for different situations with PowerShell. So you can actually, when we look at these and we drill down, we can see how they're kind of parsed out into this markdown file. And we'll see an explanation. We'll see the supported platforms. We'll see any inputs to that test and the actual commands that could be ran. Also, as well, cleanup commands, prereq commands, and get prereq commands. Great thing about this is that this is all driven by this other file called, it's a YAML file. And this YAML file is what generates that markdown. So it makes it more readable for most people. And with the atomic test, you can actually see each individual test. And this is what Atomic Operator will use to drive the execution of this code automatically for you. But just like anything, having that YAML file is great, like I said, but you have to have some delivery mechanism. And that delivery mechanism is we need something to operate, to take that data that has been defined by the community and make it actionable. That's where Atomic Operator comes in. Atomic Operator is an open source tool, like I said, that I wrote for my needs, but it kind of expanded, and now it's a larger project. But it's a Python package, and it is used to execute those atomic tests or Atomic Red Team test atomics across multiple different operating systems. And we'll talk about all the different features next. So a little bit about why I created it. So I needed a way to test a lot of different products, and have the ability to just test: A, are we detecting things correctly? Do we have the correct detection rules? A lot of my job is I interface with pretty much every single security product known to man at my company, because we have integrations for them and everything else. But we have to build a lot of automation around that, and we are the drivers for a lot of that. So I, we need a lot of data, and we need to be able to test different products. So I use Atomic Red Team just for that, just to kind of generate alerts, build SIM, build detection rules, build automation around those use cases and response, and so on and so forth. I also use it to, again, test different specific products. So testing EDR tools, SIM tools, whatever it is, whether it's Elastic, Splunk, or CrowdStrike, or Microsoft Defender, or any of the other, hundreds out there. We use them to test all the time. And I dabble in a little bit of, I guess you could call it purple teaming or whatever, with defensive evasion, and how I can understand how an adversary could leverage evasion, basically. Plus, there's tons of other, reasons, but these were kind of the core reasons that I needed it. I also needed Python, and I needed it because I deal with a lot of Linux hosts, a lot of CentOS. PowerShell is great and it works, but it's not native. So I needed something that I use from the day to day, which is Python now. But now let's get into the features. So Atomic Operator can run tests on Windows, Linux, and Mac OS systems, both locally and remotely. What that means is that if I'm on a Windows host, I can SSH into a Mac OS or Linux if it's open and run those tests. If I'm on Mac OS or Linux, I can actually remote into a Windows host using PowerShell remoting, or vice versa. Any combination thereof, which is a huge winner from the project. That's kind of one of the main drivers that I think sets it apart. There's a command line tool, and it's a importable Python package. Most familiar, you're probably going to use the command line tool. We'll get into that in the demo, but you can also use it as an importable Python package as well, meaning you can integrate it into your own automation or own scripts as needed. You can actually select and have it prompt you different inputs or specific tests, and there's other options around that where you can actually drive it via fully automated or interactively. And you can automate it even further via a true configuration platform. And I'll show you what that looks like in the demo. First thing you need to understand with Atomic Operator, though, is that it is Python 3.6 and greater. So Python 3.6 to 3.10 at the time of this recording. Also, you can find the repository under github.com/swimlane/atomic-operator, or view the documents, which if you just go to atomic-operator.com, it'll always redirect you to the latest documentation. And you can view past versions if needed. So first thing we need to do is, when you get it installed, is pip install atomic-operator, and you're off to the races. All right, now let's get into the demo. Okay, now let's get into the demo. The first thing we want to do is, make sure you have a shell. I'm using Mac OS, but you could use, another operating system if you want. Just make sure you have Python 3 and pip3 installed. If you do, then you could just go ahead and type in, let's say, pip3. I'm actually going to use Python 3.6 because of my environment, but pip install Atomic Operator. And you can see it's installing straight from pip, and we're good to go. So I'll clear out. One thing that you'll notice once you actually have it installed, you'll be able to automatically just kind of access the command line feature, which is probably the most useful and probably the way most people will actually use Atomic Operator. But you can access it via, just typing in Atomic Operator, of course, and just typing enter. And so what that'll do is basically tell you a couple different functions. So there's a built-in help system. It's kind of dynamic, meaning that if you type in the wrong command, it will automatically, tell you, hey, you typed in the wrong command. Try this. But it uses Google Python Fire, if you're not familiar, but it is a better kind of modern command line tool. Anyways, you have kind of the brief description here, and really it's all about understanding what the kind of format of this is, of the help. So you have the name, synopsis usually, but then command. So the synopsis is basically telling you, okay, type in Atomic Operator and then some command. And really, there's only three commands available in the command line, but they have different options for each one, of course. So Atomic Operator command run is probably going to be the biggest one. But first, typically you would run like get atomics. And what this will do is actually download the Red Canary Atomic Red Team project, the entire repository, into your local system based on whatever path that you're located. So you can just type in atomic operator, and we'll just type in get atomics. And once we do this, you'll see kind of the response there, and it kind of gives you the path of where to actually download it to. If I was to ls, we would actually be able to see to atomic operator, and then red canary, blah, 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 and you'll be able to see that entire repository is right there. So once we actually have that installed, then we can actually start running tests if we want to. There's a lot of different options, but I first recommend that you use the help. So we'll run atomic operator and then use the run command. We will actually type in --help, and it'll print out all the help. So these are a lot of different parameters and a lot of different, I'll kind of go through these, but I wanted to show you as I scroll up the different methods. So as you can see, this is the main method in which we run the atomic test. There's a lot of different flags and arguments, and those are listed below. You again just have a basic description and args, but the arguments are where you need to actually pay attention. So with atomic operator, when you use the run command, by default, it will actually run all techniques. So it'll actually prompt you, and hey, do you want to make sure? But it will run all techniques. So if you want to run all of them, great. You don't have to do much. But if you want to run a very select few, then you actually have to start typing those in. And we'll show you that. Same with test GUI IDs. Within the atomic or an atomic file, let me actually switch over and I'll show you. I'll just use one as an example here. And you see this auto-generated GUI ID in this atomic. This is the test GUI ID for that single test. So you can specify that specific test in the command line. All right, let's go back here. Additionally, you can actually pass in a parameter. It's called select test. So if you pipe in, all the techniques, and you want to actually select individual tests from each one of those techniques, which would be a lot, but you could do that, and it'll actually prompt you and have you choose like a multi-select window. By default, we already know the atomic's path since we actually already downloaded it. So we'll search for it and try to find it. If you put it in a different location, then you need to provide that path as part of that parameter. By default, if you just ran atomic operator, get atomics, and then the run command, it already knows that path. Check prereq. So this is by default, it is false. And this is a prereq command that we will actually, want to check. Meaning when I look at this like an atomic test, that wasn't a good one. There's this get prereq command and basically prereq command. The prereq command here is really check prereqs. And the get prereqs down here is the get prereq command. So it'll run those dependencies. A lot of times those are already there if you're experienced and you use Atomic Red Team. If not, then you need to actually specify, hey, I want to run the get prereq command to download any arbitrary, let's say, files, or just to check, hey, do you have PowerShell installed? Or hey, do you have this rootkit installed? And or the binaries to build that rootkit. And same with get prereq will actually check to see if it's there, and then the get prereq will actually download any of those or make sure that any of those prereqs are there. There's a cleanup command, -- cleanup. This is also by default off, but basically you can run this cleanup command that's defined in that test. or any test, and automatically, run that at the end. Basically, the order will be if you selected all of three of these options: the check prereqs, get prereqs, and cleanup. The order would be prereq command. Well, it'll actually be get prereq, then the prereq command, then the command will actually be ran no matter what, and then the cleanup command. So just be mindful of those inputs. There's also by default, we'll try to copy all source files. It's pretty accurate. There are some probably bugs out there with it since it's hard to test every single copy, but for the most part, my testing and some of the tests that I've written, it seems to be like copying most of those source and bin files. But if you run into any issues, just let me know. We'll get it fixed pretty quick. So this will, by default, copy all those source files when you're doing a remote connection to that remote host. Command timeout is really all about, hey, if there's some sort of connection issue or something like that, we'll actually wait for 20 minutes, or I'm sorry, 20 seconds. And then if we didn't get a response, then we'll actually, fail and say, hey, this failed. You can run debug or debug logs. It'll actually just output a lot more detail about the test being ran. And prompt for input args. This is another option where if you do not know the inputs. So for example, if you're not familiar, here's a test. There's input arguments that are defined: rootkit source, rootkit path, and rootkit name, and tint folder. So all of those have a default value, and we'll replace those for you automatically. But if you wanted to specify an alternate value besides that default, then you can actually have it prompt you and to enter what that value should be. This is more interactive. Probably you're only going to use this when you're doing like one test, one or two tests. If you do all of them, it's going to take you a while to kind of go through them, but it is useful. Return atomics. So this is actually something that I needed, but it is useful for others as well. If you didn't want to run those tests, but you want to just return the parse structure of those atomic tests, then you can just do that. And it'll literally return custom models and objects that are parsable and can be converted to JSON and DICs and all this other stuff from return atomics. So you just pass that in and it'll return those instead of running. We'll get to this, but this is an optional configuration file that you can provide that allows you to run a lot of remote tests or just tests in general with different configurations. And there's also this config file only. This is very specific kind of use case, but if you passed in all techniques, but you only really wanted to run, you accidentally, pass it in, then you could actually say, oh, only run the ones that I've defined in my config file. When we get into the next kind of set of parameters, I know this is a lot, but we have host. So you can actually provide one or more hosts. And if you do, then we will attempt to run those tests not locally, but remotely. And you must provide a username at least for each of those hosts that you've defined. If you have different authentication for each host, that's where the config file will come in, and we'll explain that. You optionally, you need to provide a password and or an SSH key path or the actual private key. And this is only for SSH, so typically that would be Linux and Mac OS systems. And username and password are used for Windows Remote Management or WSMan. You can also verify SSL, especially over RDP. Typically, you won't come across this. A lot of people don't have SSL on for RDP, but if you do, great, use it. And you can specify a different SSH port for that host, and as well as the timeout value for that SSH connection. There's additional flags that can be accepted, but basically those will be a dictionary, and they'll map them to the input name and their values. Again, this is probably something you wouldn't use a lot, but you could. Okay, I know that was a lot. There was a lot of inputs there, a lot of options, a lot of features. I definitely recommend whatever you do is to open up and go to atomic-operator.com. You can list out a lot more detail about those inputs and how to use them in certain situations. So if you find anything missing or anything, documentation, maybe you're afraid or you're just not familiar with code, documentation, I will happily always accept documentation updates. I am not a document writer. I try to explain as best from my perspective, but I wrote the thing, so I have a different view on the project than others. So please submit documentation updates or anything like that. And if you have questions on how to do that, let me know and I'll answer. Okay, so let's take a look at that run command. And what we want to do is we actually want to run techniques, and we will attempt to, so we will go ahead and start to look at the atomic operator run command. We will do atomic operator run techniques. I'm going to specify a very specific one, and I will just provide the basic details and not provide any of those other switches and hit enter. What this will do is it'll run and it'll start outputting some logs, and we'll see that here soon. And the main thing that we'll see is that, okay, I provided that technique, and that technique has individual tests within it, right? One or more tests. And you'll notice that the first kind of info print here is that that test specifically is for Windows and is not supported on my operating system or this operating system. So it's skipping. Same with this Windows firewall. Again, I'm on a Mac, and it'll say, hey, you can't run this on this operating system, so we're going to skip. The next one, it's going to say, oh, all right, we're going to run this one. And this is the actual output from that ran test. So we can see the entire dump of my network information or whatever, all right there. And then it kind of goes through and it does the same thing for the other ones because A, they're not applicable to my operating system. So we kind of built in that logic to make sure that A, you're not trying to run Windows or whatever on your local machine when it's not Windows. But we still kind of output that to say, hey, we did skip it. So you just kind of acknowledge that. The other thing is that we'll run Mac OS firewall rules. For some reason, I'm getting a command timeout. And that could be for a lot of different reasons, mostly because probably my system is fairly locked down. But you can see also that each individual test that was ran will actually output their kind of in a JSON object kind of output that you could pipe it to wherever. And it kind of has the format of the test GUI ID, where you ran it, whether it was a remote or local host, the command, and the technique ID, and the command is like the output. And you'll see that right here. So the other one, since it didn't actually run because we got the warning command actually timed out, then we actually failed back and still say, hey, we tried to run it, but we didn't get any response. So you can kind of use that data as you need, but we can tell that, hey, we have ran this test, and you can see that we have a lot of different timestamps already available for us. Some of the cool thing about atomic operator is that we do output all of it to a log file. So everything that you saw in that console will be printed out here. And there's going to be different ones, for errors. There's going to be error. There was no errors. Warnings, you're going to see, hey, we try to run that, but command timed out. So you'll have different logs for different types of data. So if you ever need to troubleshoot or, just you want to save it and look back, we'll have kind of a running log always outputted to wherever that package is actually installed. Okay. So let's take a look at atomic operator, and we will actually do the techniques, but I wanted to select test. I think I spelled that right. So it's going to go through, it's kind of iterating through, and you can see that it will actually prompt me to select which test I want to individually within that technique itself, and you can actually select individually or more than one, right? I think it's just these, and I can actually select those and run just those tests. So again, my output is a lot less. We're actually going to see that we only selected and we ran that first test, which is here's the output. And we're actually running that second one. It's asking me for my password. I hit enter, blah, 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 and blah. So you can actually go through and select individual tests as needed. So if I wanted to run that select test, but I want to check prereqs and get prereqs and clean up. Again, it's going to prompt me, and I'm going to say I just want this one, and go. So good thing about this is that it really didn't have any. It didn't really have any prereqs, basically, because there's no output, because there was no commands to being run. So you can kind of see where that is. I'll have to maybe put something there to kind of say that, hey, we attempted, but there's none. But right now, it's just no output. Okay. So that's pretty that's going to be most of your, typical use cases, right? Again, you can actually just say, hey, I want to return all atomics. Actually, I'll do that. So if I leave techniques blank, and we just want to return atomics, it'll actually iterate through every single atomic defined in every single test, and it's going to dump a bunch of data. But you can see there's an atomic, and these are different models for each atomic and their test. And they're barely accessible by their property names, and they can be converted to JSON and blah, blah, blah. So you can pipe these, especially from the command line, it's a little bit more difficult. When we get into the Python package import, you'll be able to use this data a lot more. And I'll show you what that means. Okay, so let's look at our help again. And let's take a look at config file, blah, 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 command timeline. I mean, those are pretty all straightforward. I'm actually going to show you, and I'm going to actually move my me over here, because I'm going to try to run this test without showing you any passwords. Let's say hosts. Yeah, you can't see any. Cool. So let me move me over some more. Okay, so I'm actually going to try to remote into a specific host. and run some tests, run that test. And so you'll see kind of the output as we go here. Let's see, running, it's running. Oh, I know why. Sorry, guys. I wasn't connected to my VPN. You know, demo's live, right? Fun times. All right. So now we're going to run it again. And we'll actually run that out. Let it kind of process here. And of course, because I chose the wrong host. That's what I get for using my history here. There we go. So you'll see that it'll just start running, and it's running every single one of those tests that it can on that remote host. This is a CentOS box that I ran it on, and we'll kind of scroll up a little bit just so we can see some info. We can see that, hey, we're going to skip this. We are running those different tests. It's going to try to run those because it's hard to actually determine what operating system you're in. Especially from a remote, if you haven't specified specifically, hey, this is Linux, hey, blah, blah, blah. I was going to add an option for that, but so far, it's just kind of noise. So you can see that there's a warning connection error because, hey, I'm trying to connect over a Windows protocol on a Linux box, but we can kind of skip down and you can start dumping out information from that host. And again, similar output that you're going to see. Basically, because ARP is missing on that machine, it's going to skip everything running around ARP. You can see that we're running these other commands and request open. We're going to try to run this temp. And so you can see that we've actually converted in this test this actual PowerShell script path to a temp path, and it'll actually run that on that host because it does have a remote PowerShell on there, or I'm sorry, it does have PowerShell 4 on that host. And you can kind of see some more authentication successful. I mean, there's lots of logs and lots of information being dumped out, but we're able to actually run those tests all remotely from that host, which is pretty cool. So without taking too much time, I want to show you one kind of last thing. And this is going to be the configuration file that we talked about. So with Atomic Operator, you can actually, pass in that config file. And I'll let you kind of go through your docs for that, but let me try to get there. Oh, there. So we will, we have this kind of inventory, and the entire document is all in YAML. So if you're not familiar with the YAML, please get familiar because it's pretty common for config. But I enjoy YAML because it allows me to do what I'm about to show you. So the minimum that you're going to need for a single, for running a test would be literally atomic test, and we don't even need any of this. You could just specify the GUI IDs. So you can literally just have this, and you know which GUI IDs that you want to run, and it'll actually show you that. So that's the absolute minimum. Secondarily, you could have something like this, where I'm actually just going to copy this again and show you down here. So you can have, you want to specify for each one of those tests some input arguments. So remember, we have those default values defined in that test where you can actually change them here and kind of automate around them. So depending on your, how you're set up or how you're going to use this project, but you could actually, swap that value, and when it runs that test, it'll just replace whatever that argument input file or whatever the name is for that input argument with whatever value you provided. So again, this is all local. Same with the other example. But let's say you wanted to run tests across multiple different operating systems, and they have multiple different configurations. Configurations is what I mean is authentications. So with this kind of format, we can actually have a lot of different layers. So with this atomic test, we can actually provide an inventory. And an inventory is a list of one or more computers or systems that you can actually define their authentication credentials for. So we can say for this test, I actually want to run, which this you would never really do this, but this is an example. You could actually say for this test, let's actually make one. We'll say Linux 2 group, and maybe even macOS 1 group, right? So we have these kind of inventories for this specific test. And in our inventory key right here, we can actually define different sets of inventories. So you can say for Linux 1, I want to use the SSH executor, meaning I want to run these over SSH. You provide that authentication for that group, that group of hosts, and then you have one or more hosts under that group. So I could say for Linux 2, I want, and I'm just going to copy this again. I want, where am I at here? I want, I'll just get rid of that. I want username and password. I'm just going to leave all that other default, and I'm just going to, change these to whatever arbitrary, IPs or domains that I want. And at that point, now I can say, I could have, hundreds underneath there. And they are all going to use this one set of credentials that I provided. Or I could have 2 in this one, or 1 in this one, so on and so forth. So you can kind of have a layered approach, and you could build this out over time as you begin to test, and actually just automate the entire running of all those tests, their inputs, and the authentication mechanism just by passing in this configuration file. So it's pretty useful, especially when you want to automate on lots of different hosts across lots of different types of environments and different environments. Maybe you're in an MSSP, maybe you're not. Yeah, you can run these in multiple different environments or networks as you see fit. So configuration file is out there. There's an entire large document kind of explaining that a little bit clearer. Please, again, read through those documentation and make sure that you're following there. Last thing, I want to actually show you the README. And we're going to, look at, we kind of support Python 3.6 to, I have to change that to 3.9 or 3.10 since it's out on Windows, Mac, and Linux. We kind of have the why and the features, but then you can dive into different pieces of the documentation, which is all rendered on that atomicoperator.com. But if you just wanted to see it from the repository, you can view it there as well. Look at the requirements, how you install. There's certain caveats when you start getting into Windows. There's some prereqs basically that you may have to check. Like, let me go here. Basically, you need to make sure that PowerShell remoting is enabled and WinRM is set up, and you're allowed to remote into that system. So I kind of have some PowerShell code that you can use to help troubleshoot or to get it going on a Windows host. So I hope that helped you understand Atomic Operator, how you can use it, how it can benefit you. If you have any questions at all, please let me know. you can reach out to me on Twitter, GitHub repository, or in Slack, or in Discord, wherever. I'm all around everywhere. So thank you all, and have a great day.